And now that you have an understanding of the makeup of graphs, let's see what GraphX can bring to the table to simplify graphing. Here, I've preloaded a script that sets up a family graph so that we can see how easy it is to execute one of the more common graphing algorithms, PageRank. First, we have a couple of imports. The first sets up our base GraphX namespace so that we can use classes like Edge without the namespace baggage. The next is to explicitly pull in the graph object so that we gain access to an implicit definition which enables a number of additional operations on our graph. The conversion takes our graph and wraps it in a GraphOps class, which you'll need to do explicitly in Java. But don't worry, I'll make sure to point out the usage when it's encountered. Then we create a person case class, which we're using to wrap the name and age information for each of the family members. Note that each family member has a unique ID, and the pairing of ID and person is wrapped in a tuple too. That combination makes the resultant family RDD end up being our collection of vertices. Then, the next RDD that we create is our edges, with each edge representing a familial relationship, set up by connecting the source vertex ID and the destination vertex ID, along with additional metadata on what kind of relationship it is. With our vertices and edges set up, it's trivial to join them as a graph. Simply wrap them in a graph, vertices followed by edges. Note that in Java you'd need to call graph.apply, which is really what's being called behind the scenes for the Scala anyway. Now, we can hit Ctrl+D to execute the script and create these objects. Once created, it's actually extremely simple to calculate the PageRank of the graph. Simply call the PageRank method, which really resides on the GraphOps class, only supplying the tolerance level to which we want our ranking algorithm to converge, with a smaller number leading to a higher accuracy. Once the calculations are done, we can use Graph's vertices method to get the list of, well, vertices, where the vertex property data is now a number representing the PageRank. And if we're trying to read this as is, it would just be a list of vertex IDs and PageRanks. So we'll join our family object with the ranks so that we get actual person information instead of an indecipherable ID. Then, to make our results easier to reason, we'll sort by the PageRank, which happens to be in our pair's value, in the second position. Finally, we can collect this data to our driver, mash it into one string separated by new lines, and print it for review. Here we can see that while my daughter only has 2 links, they're strong, giving her the highest ranking, followed by me, whom the entire graph is based around. So, it seems to have worked as expected on this very simple set. The specializations made for graphing mean that it runs pretty efficiently also. And it would be just about as simple to run graphing's triangle counting or connected components algorithm, which are also built right into the GraphOps class.